continuing on, we're going to take a look at how to analytically deal with one-sided limits. 2 bullet points here. First of all, to analytically evaluate a one-sided limit of a non-piecewise function, we're just going to plug in. To analytically evaluate a one-sided limit of a non-piecewise function we are just going to plug in. I guess I should add in something in parentheses, as long as the function is defined. To analytically evaluate a one-sided limit of a non-piecewise function, we're just going to plug in as long as the function is defined. So let me show you what I mean by that. Let's take a look at the limit as x approaches 3 from the right of x squared plus 4x. Well, all that I need to do here is just plug in the 3 where the x is. I'm going to ignore the little plus sign that means to the right. I'm just going to say 3 squared plus 4 times 3. That gives me 9 plus 12, and I'm going to get 21. The reason I can just plug in is because, well, this is just a parabola. And as I approach 3 from the right, well, that's the same as if I approach 3 from the left, which is the same as the value of the function right there. I'm perfectly continuous. I'm just going to plug in. You try one of these on your own. I'd like to see if you can go do the limit as x approaches -1 from the right of the square root of x plus 1. See what you can do. I'm going to plug in, I'm going to get -1 plus 1. I'm going to get 0. One thing that I do want to mention, though, that's a little bit strange here, that one-sided limit wasn't a big deal, but if I change the problem into the limit as x approaches -1 of the square root of x plus 1, that doesn't exist. Any thoughts why? And if you're not sure, that's okay. Any thoughts? Well, if we take a look at the graph of this thing, I know it's a square root function, a half parabola moved 1 to the left, so my graph looks like this. As I'm approaching -1 from the right, sure, my y's are approaching 0, but I can't talk about anything to the left of -1. I don't have any limit because I don't have any function there. Therefore, I can't talk about the overall limit. Next, let's make these a little bit more interesting and move into piecewise functions. To analytically evaluate a one-sided limit of a piecewise function, we're still just going to plug in, but we need to make sure we plug into the appropriate side. To analytically evaluate a one-sided limit of a piecewise function, we are still just going to plug in, but we need to make sure we plug into the appropriate piece. To analytically evaluate a one-sided limit of a piecewise function, we're still just going to plug in, and we need to make sure we just plug into the appropriate piece. So I'd like to take a look at the function f of x equals x when x is less than or equal to 1, and 1 minus x when x is greater than 1. We'll take a look at the graph of this thing in a little bit, but I'd like to try to figure out the limit as x approaches 1 from the left of the function, and also the limit as x approaches 1 from the right of that function. Both of these will just involve me plugging 1 into this function. However, if we are a little bit to the left of 1, which piece are we on? Are we on the top piece or are we on the bottom piece? Hopefully you realize if we're a little to the left of 1, we're on that top piece. So rather than dealing with this function f of x, how about I write it out as the limit as x approaches 1 from the left of, well, that top piece is just the function x. I'm going to plug in 1, and I'm going to get just 1. If I'm doing the limit as x approaches 1 from the right of the function, well, if you're a little to the right of 1, that means you're on the bottom piece over here, and you're going to do the limit as x approaches 1 from the right of 1 minus x. That's going to give us 1 minus 1. That's going to give us 0. As I approach 1 from the left, my y's are going to approach 1. As I approach 1 from the right, my y's are going to approach 0. Let's take a look at this graph. So I'm going to take a look at this graph in Desmos. You're welcome to play around with this website as well if you'd like. To input a piecewise function, I'm going to type f of x equals. And then the syntax for a piecewise function is I'm going to start with a left open set brace. I first give the inequality, colon, I give the function. So I'm going to say x is less than or equal to 1. I'm going to say x is less than. To make that an or equal to, I'm just going to push the equal button. And then colon x, comma, the next piece. So I'm going to say x is greater than 1, and the function there is x minus 1. And we can see that, yeah, what I'm looking at agrees with what I just calculated. The limit as I approach 1 from the left of my function is positive 1, and the limit as I approach 1 from the right of that function is 0. Okay, hopefully that worked. Let's see. Let's take a look at one other piecewise function. Let's make this a little more complicated. Let's look at f of x, which equals 3x minus 1 if x is less than or equal to negative 1, x squared plus 5x if x is between negative 1 and positive 1, and 3x cubed when x is greater than or equal to 1. We want to find two things here. We want to find the limit as x approaches negative 1 of the function and the limit as x approaches 1 of the function. We want to go try to find both of those limits. Pause the video if you need another moment to copy things down. But before we continue, I'd like to go back to our flowchart for evaluating limits. We are still evaluating a limit as x approaches a number, so I'm going to continue following this branch over here. And now I'm asked the question, is the function piecewise for absolute value or step? And I'm going to say that yes, my function is piecewise. So I'm going to follow that yes path over here, which says I need to split my limit into two separate limits, a limit from the left and a limit from the right. I didn't have to do that in the last problem because it was already a one-sided limit, so I just left it alone and plugged into the right place. But because I'm trying to deal with an overall limit here, I'm going to split. Once I've done that, I'm going to plug into the limit, plugging into the correct piece based on the direction. And I'm going to see if I either get a number over a number and I'm done, or 0 over 0, which means I'm going to have some simplifying to do. Let me actually write this out over here in parentheses to do what I'm asking. We're going to find both one-sided limits. If they're equal, then that's our overall limit. If they are not equal, if we're approaching something different from the left and something from the right, our limit does not exist. We are going to find both one-sided limits. If they are equal, that's the limit. If not, the limit does not exist. So at x equals negative 1, I want to do the limit as x approaches negative 1 from the left of my function. I'll figure that out in a moment. and then the limit as x approaches negative 1 from the right of my function. Once I'm set with that, then I'll go back and figure out the overall limit. If you're to the left of negative 1, what piece are you going to be on? Top, middle, or bottom? Hopefully you said top. I'm going to plug negative 1 into the top. Make sure you're being good with your limit notation. Limits until you actually plug in. Let's see, negative 3 minus 1, that's negative 4. If you are a little to the right of negative 1, what piece are you on? Top, middle, or bottom? A little to the right of negative 1, that's like negative 0.9 or so. That's that middle piece. So I'm going to plug negative 1 into that middle piece. And I'm going to get negative 1 squared plus 5 times negative 1. That's 1 minus 5. That's negative 4. The limit from the left was negative 4. The limit from the right was negative 4. So the limit as x approaches negative 1 of the function in general is going to be negative 4 because the limit from the left equals the limit from the right. I'd like you to take a moment and I would like you to go through a similar analysis at x equals 1. Do the limit as we approach 1 from the left of the function, then find the limit as we approach 1 from the right of the function, and then figure out the overall limits. Take a moment, pause this if you're on YouTube, if you're on Edpuzzle, do your limit as x approaches 1 from the left, and then you'll submit that answer. Okay, so the limit as we approach 1 from the left of the function. If I'm a little to the left of 1, I'm on that middle piece. So I'm going to plug 1 into that middle piece. I'm going to get 1 squared plus 5 times 1. I'm going to get 6. Now we need to figure out the limit as x approaches 1 from the right of the function. Take a moment, go do that. I'm going to plug in, if I'm a little to the right of 1, that means I'm on the bottom. That's going to be 3 times 1 cubed. That's going to be 3. So now, because of that, the limit as x approaches 1 in general of f of x, take a moment, figure that one out. That overall limit doesn't exist because I'm approaching something different from the left and from the right. Let's check this. Let me show you what the graph of this looks like. So again, I'm going to take a look at this graph in Desmos. I'm going to type in my function as f of x equals left set brace to get this started. I'm going to say x is less than or equal to negative 1 colon 3x minus 1, comma. Next piece is valid between negative 1 and 1, so negative 1 less than x less than 1, colon, x squared plus 5x, comma. Last piece is valid when x is greater than or equal 1, colon 3x cubed. First, I was dealing with x equals negative 1. I found the limit from the left was negative 4, same as the limit from the right. So they agree, and yeah, I see that's what I'm looking at on the graph. At x equals 1, the limit as I approach 1 from the left was 6, and that's what I see there. And the limit as I approach 1 from the right is 3. That's what I see there. So yep, this agrees with the fact that my overall limit does not exist. Okay, again, hopefully that graph worked. Let me show you 2 more variations on this. Let's take a look at the limits as x approaches 3 of the absolute value of x minus 3 over x minus 3. I'm going to go and I'm going to plug into this thing because that's how I should usually start this. I'm going to plug in 3 and I get 0 over 0, which means I need to do some simplifying. But I can't really factor and cancel this. I can't cancel the x minus 3 from inside the absolute value bars with the x minus 3 on the bottom that's not inside absolute value bars. What we need to do is actually go back to something that you saw in the summer work. I mentioned in the summer work that we don't want to deal with absolute value functions in calculus. What we want to do instead is rewrite them as piecewise functions, which will make them a lot easier to deal with. So I'm going to go say rewrite as a piecewise function. I'm going to split this at whatever makes the thing inside the bars equal 0. So I'm going to say x minus 3 equals 0. That means I'm going to go do some splitting at x equals 3. I'm going to say f of x equals. Okay. Well, one piece is going to be good when x is greater than 3, and one piece is going to be good when x is less than 3. I'm not going to have a piece right at 3 because we already saw if we plug in 3, we get 0 over 0. That's no good. If you plug in something a little bit greater than 3, like 3.1, 3.2, whatever, the stuff inside your bars is going to end up being positive. And to take the absolute value of a positive number, you just leave it alone. So I'm going to say that that is x minus 3 over x minus 3. If you plug in something a little less than 3, like 2.9, 2.8, whatever, the stuff in the bars, 2.9 minus 3, that's a negative number. How do you take the absolute value of a negative? You change its sign. So I'm going to say that that top is negative x minus 3. Realize that this negative doesn't mean negative. It really means the opposite. This thing over here was already negative, so this sign is changing that negative into a positive. I'm just changing my sign over there. And this is my new function. Well, I can simplify this. Actually, this is going to simplify really nicely. This is going to become 1 when x is greater than 3, and negative 1 when x is less than 3. Well, I want to find that overall limit. Because I'm trying to do an overall limit of a piecewise function, I can't jump right into that. I need to go do the limit as x approaches 3 from the left of that function. I need to then find the limit as x approaches 3 from the right of that function. And then I'll use those two answers to get the limit as x approaches 3 in general of that function. Take a moment and do those 3 limits, and let's see what you can get. And you'll submit your answer through Edpuzzle. If we're a little to the left of 3, that means I'm on this piece over here. I'm going to plug into this constant function. I'm going to get negative 1. If I'm a little to the right of 3, I'm going to plug into the top function. I'm going to get positive 1. So, because those two are different things, that overall limit does not exist. Take a moment, go graph this on your calculator and see what this looks like. Not the piecewise version, that's kind of complicated, but go graph that original function on there. You're going to type in y of x equals, actually let me grab my calculator. To get the absolute value function, if you push math, go over to number. That first option, ABS, means absolute value. So I'm going to say x minus 3. And just to be safe, I'm going to put parentheses around that whole thing. Then I'm going to divide by x minus 3. I'm going to set my window. I think that window looks okay. And I see that it jumps like that. My graph is going to look like this, and then like that. One more. Let's take a look at the limit as x approaches 5 from the left of the absolute value of 5x minus 25 over 5 minus x. I need to start by figuring out where to split this function. See if you can figure that out. Where are we going to split this function? Well, we're going to take the stuff in the bars. We're going to take 5x minus 25. I'm going to set that equal to 0. 5x equals 25. X is going to equal 5. I'm going to split this thing at 5. F of x equals. Okay, so one part where x is greater than 5, one part where x is less than 5. Oops, you can't see that. Hopefully now you can. Okay, well, if you go to plug in a number greater than 5 to the top, will the stuff inside the bars be positive or negative? You plug in something a little bigger than 5, 5 times something a little bigger than 5, minus 25, that's going to be a positive number, which means we're just going to leave it alone. And I'm going to say 5x minus 25 over 5 minus x. Plug in something a little less than 5, 4.9 or whatever, 5 times 4.9 minus 25, that's going to give you a negative number. So I need to change the sign of that negative number. That's how I'm changing my sign up front. I'd like to see if you can finish this problem off. Do some simplifying. Make sure you're careful with the denominators. And then see if you can finish this off. Okay, so f of x is going to equal, up top, you know what, before I do anything, I'm going to just rewrite the denominators so they're in standard form. It's going to make it a little bit easier to see what sort of simplifying work I'm going to have to do. Oops. Guess I should have shut off my phone. And then I'm going to get something like this. I'm then going to go take out my GCFs. Up top, we're going to take out a 5 and get 5 times x minus 5 over, on the bottom I'm going to take out negative 1 and say negative 1 times x minus 5, and oh, that's nice, that's going to cancel. The bottom, I'm going to take a 5 out of the top. I already had a negative out front, so that's a negative 5 over negative 1 times x minus 5. That's good when x is less than 5. So my function f of x is going to be negative 5, going to be greater than 5, and 5 when x is less than 5. Finally, we need to go and answer the question. I want to do the limit as x approaches 5 from the left of my function. I actually don't even need both of these pieces. I really just need that bottom piece. When you're to the left of 5, you're going to plug in over here, and you're going to get a positive 5 for your limits. There's no need to do the limit from the right because I didn't ask you about the overall limit or the limit from the right. I just asked you for the limit as we approach 5 from the left.